When we do sets, when we do shading, we always tend to look at the question itself. Obviously, you got to see the question to do the question, but you have to see what expression they give you. Example, we have this tree set thingy. Let's draw it. A, B, and C. It's a bit wonky though, but generally you will have like a proper thingy, you know. Mine's even more wonky than theirs. Oh, there's any 3 circles. They don't care. When you have the union means you add the sets together. So here what we do, we shade in, we have the part A union B. It means A and B. A and B. Done. That's your answer. So you know how we add them. Now what does this intersection mean? We'll come to it in a second. Let's first do part B. So this is part A. Copy, paste. We want to make multiple of these, so I will first do make these, paste 1 2 3 4. To remove to solve your problems, you have to remove the problem itself, you know. That's what I say to algebraic fractions. B, you know how a union is adding, so we do A and B and C. Nice, beautiful. C, A union B prime. What does B prime mean? It is B, it is the things outside B. Let's first do A, then and outside B. What area is outside of B? Well, outside B is everything except shading B. See, like so. This is a prime. This is B prime. Okay, this blue area that is shaded. This is B prime. It is outside that set, outside that expression. Yada yada yada. Example, this B union C. If we have B union C, and in that bracket prime, example, we have B and C. B and C. But it has the prime in it, meaning we shade things outside this region. So what do we actually shade? We shade this sort of region. We are not touching these B and C circles. We are only touching the areas outside this in the expression B union C. So when it says B union C, we shade this expression here. So union B prime A, so we shade this outside region. Nice. See, D, A intersection B union C. Now what does intersection mean? Intersection is literally what you would expect. Example, we shade A, we shade in A, and we also shade in B. You see this dark area? This is your intersection. So if we shade in this means this is A intersection B, and works for any case. Expression, intersection, and expression. We shade the intersection of the two expressions. Here we want to shade A intersection B union C. B union C is this area, and A is this area. If we shade in their expressions, this so far shape thingy, we have this answer as D. Got it? You don't. Stop time. B union C. A union B intersection C. So you do A union B intersection C. Now C is like this. C is like this. You see this denser area? It's like a mustache thingy. And that is our intersection. Nice. F. A union B union C prime. Now B union C prime, what was that? Let's first shade A. I told you A union B union C prime was the area outside this region that I shaded in like this strawberry red color. So we do outside this region. It will look messy. You guys can use your pencil. Remember, you have to use your pencil for shading 100,000%. This last one. Part G. How do you do part G? Well, that's a very good question. A intersection C union A intersection B. Let's take this slowly. You know board mass. Brackets first. So A intersection C reminds us of this area. A intersection B reminds us of this area. And union means to just add. So it means this sofa thingy. Yes, the sofa is the same as A thingy. I don't know which one it was, but sometimes the expressions are just like this. It's like where it looks the same, but you can obviously 100% simplify. They will ask you to simplify this expression and write it in another form, in another method, blah blah blah. You do not have to be scared about that. You are grown up. There's nothing to worry about. Now, the second one. In a class of 30 students, let's do A, B, C, D, E, F, G, 6, 7. In a class of 30 students, 22 like classical music, 12 like jazz, 5 like neither. Using a Venn diagram, work how many students like both classical and jazz and J's. Let's draw the diagram. What do people like? Classical music and jazz. So there are two components, jazz and classical. Let's just do it in order of the question. Now classical will have this and jazz will have this. Let's see the setup. There will be the total count of our universal set will be 30 people. 22 like classical music, so C is equal to 22, and 12 like jazz, and classical union jazz prime is 5, meaning there are 5 people outside. What are we given? There are 5 people who like neither. So if there are 5 people who like neither, since C union J should be 30 minus 5 is equals to 25. This must add up to 25, this region over here. But what do we know how many people like classical and jazz together? Well, we set up a expression like a linear thingy. Let's name this x, y and z. We know x plus y is equals to 22 and y plus z is equals to what? 12. Nice. We know y plus z is equals to 12. What is 22? 22 is equals to 10 plus 12. Okay, this is a very bad analogy. We want them to, and we have the setup x plus y plus z is equals to 25. You have these three equations. Okay, this is like a linear simultaneous equation but on steroids, because you have three linear equations. This is easy. Why? You see this, y plus z. You can just plug in 12. X plus 12 is equals to 25. X is equals to 25 minus 12 is equals to 13. Wow, 13. We already got our answer, 13. Y plus z. Now y plus z is equals to 12. But x plus y is also equals to 22. You can use this fact. 13 plus y is equals to 22. So y will be what? 9. Y will be 9. Yeah, now y will be 9. Because we use the second equation, we plug in x inside here. That's why we get this. And that's why we solve for 9. So this will be 9. Now for z. We can solve for z by using the equation this. Y plus z is equals to 12. So we can use 9 plus z is equals to 12. Z is equals to 3. Nice. See, very simple. What was the question? Find out how many students like both classical and jazz music. So our answer is 9. Very good. We do not have to fill it, but it's good practice to fill it. Yeah. The silence is very awkward today. But yeah, my mouse is connected. It's charging right now, and that's why it's like moving here and there. So yeah, I hope you guys liked today's video. Got something about sets and diagrams. If you want, I can properly cover every single the entire sets chapter. Or to subscribe, get me to 200 subs, and then I will make the video naturally in my full syllabus coverage. Please like, subscribe, and share, and see you next time.